the rest of the factoring notes. So we got two perfect square trinomials. Okay, again, these can be done using the 5-step method, but if you want, you can recognize this pattern right here, where the first term is a perfect square, like 16. The last term is a perfect square. And the middle term is the square root of the first term and the last term times 2. So let me show you. For this first one, it's a perfect square trinomials and they're all add. Okay, that's important. And so the square root of 16 is 4. So in this case, my A is 4. And the square root of 9 is 3. So in this case, B is 3. So my formula then claims that the middle term should be this times 2. Let's see. 4 times 3 is 12 times 2 is 24. Check. So this is a perfect square trinomial, which means my answer is just then 4n plus 3 squared. Okay? Because it's really 4n plus 3 times 4n plus 3. And if you were to check it, you'd get 16n squared plus 12n, that's 24n plus 9. Okay? So that is your answer by recognizing a pattern. You could do the same thing if there's a subtraction. Notice that it's minus and then plus. Okay, so, and that's really funny, I didn't mean it to be, but 37 is the same problem as 36, but with a subtraction. So my answer is 4k minus 3 squared. And let's check that one. 4k minus 3 times 4k minus 3, just to prove to ourselves that this shortcut really works. So first, 16k squared minus 12k plus 9. So yep, 16k squared minus 24k plus 9. So it works. So you have two problems. With that, you can do them the long way or notice the pattern. The next one is sum of cubes and difference of cubes. I want you to notice that we have both a sum and difference of cubes when we only had a difference of squares. Where is that? Okay, there's no sum of squares. No sum of squares, only a difference of squares. For the cubes, we can do both. So sum of cubes is this weird pattern. So let's look at it. In this case, what's the cube root of x cubed? So in this case, my A is x. And what number, what's the cube root of 8? That is 3. So my B is 3. So it says my answer is going to be x plus 3 times x squared minus A times B. So 3x plus B squared. 3 times 3 is 9. Okay? Now if you FOILed that back together and canceled stuff, turn into x cubed plus 8. And I'm going to do it just one time to show you. That's going to give you x cubed minus 3x squared plus 9x. And that's going to give you 3x squared minus 9x. And 3 times 9 is, that's weird. 3 times 9 is 27. Which would give us x cubed, plus 27. Does anybody see my error? The error is that I can't do simple mathematics. This would be if this was 27, because the cube root of 27 is 3, instead of the cube root of 8 being 2. So I'm going to go ahead and change this to 2. And actually, let's change the original problem to 27. There we go. So the fact that I didn't do the cube root of 8 right is the problem. So that was 3. And it checks out. Sometimes it helps to check yourself. Okay, the difference of cubes is the same idea. Okay, what is the cube root of 8? Well, that is 2. Make sure I do that correctly this time. And so I have 2x, and the cube root of 27 is 3. Okay, so then if I follow my pattern, it's just a minus b, 2x minus 3 times 2x squared, which would be 4x squared, plus a times b. So 2x times 3 is plus 6x, plus b squared, plus 9. And again, we can check that. So I paused it and went ahead and checked, and sure enough, this multiplies into that. Okay, so those are just patterns that you may recognize. And in particular, these two don't use that regular trinomial formula. If you're going to factor something that's a cube, it has to be one of these two or it's not going to work. All right, the last type is factor by grouping. And this is kind of like step 3 on the other factoring that we did. Okay, so I'll just show you. It's adding parentheses. If you look at it, they don't all have something in common. These guys have 2's and a b. These guys could maybe be, okay, so maybe this could be divided by 3, but this can't. Oh, but they could both be divided by 7. So what we're doing is we're looking to see if they have something in common, just these two and these two, because together they all don't have something in common. So I add parentheses just like we did on that step 3 of the AC method. Both of these could be divided by 2. So I'm going to pull out a 2, and I can also pull out a b squared. And 6 divided by 2 is 3 with 1b left. 8 divided by 2 is -4. And noticing that I have a negative here but a positive here and a negative here, I'm going to pull out a -7 from these two. So 21 divided by -7 is 3, and there's a b left over. 28 divided by -7 is -4. And just like with the AC method, we know we did it right if these two match, and they do. So then we'll just factor 3b minus 4 times 2b squared minus 7. And then you can always go back and look and see if there's any other patterns like difference of squares or something in here, but I don't see one. Okay, so that's factor by grouping. Okay, 50 and 51. I'm not quite sure why they got squished over here. We can go ahead and, you should be able to do them anyway. All right, lastly, solve by factoring. Okay, and there are some steps for this. Why do we factor? We factor so we can find zeros, or where it crosses the x-axis. So the steps are, number 1, set it equal to 0. Okay, so here's our quadratic, but it's something equals something. We need it to be equal to 0, so I'm going to move all of these over here, basically by adding 10x to both sides and 16 to both sides. And this should be review from secondary 2. So you have x squared plus 10x plus 16 equals 0. And what we're doing is we're forcing our y value to be 0, so we'll figure out where it crosses the x-axis. Step number 2 then, to factor. And I'm going to do the guess and check method. I can see that this is going to be x plus 2 and x plus 8. Let's see, 2x plus 8x, that's 10x. And 2 times 8 is 16. Yep, that works. Step 3 is to set the factors equal to 0. And the reason we can do that is the zero product property. IB calls that the null product property, or the null, I think it's the product property. Okay? But that just means that if you had two numbers, let's say 2 times question mark equals 0, the only way that's true is if question mark equals 0. The only way to multiply two things together to get them to equal 0 is if one or both things are equal to 0. So we can attempt to figure out what number goes in here to make this whole thing 0, and what number goes in here to make this whole thing 0. So we will do that by setting the factors equal to 0. So x plus 2 equals 0, x plus 8 equals 0. At this point, you may definitely just see the answer and you can write it down. Minus 2 from both sides. So when x equals -2, and in this case when x equals -8. And what that means is that if you were to graph this parabola, this is -8, it's -2, it's going to do something like this. Okay, it's going to cross at -8 and -2. Those are its zeros or solutions. And you can do these 3 steps, actually it's 4 steps. The solving part is step 4. With any of the factoring that we've done so far. So we have a trinomial, a difference of squares, and just some trinomials. So try those on those 4 steps. This entire homework assignment is due next time.